So as we're looking at the size of this golf ball, how something so small can be causing such a big problem in the solar industry. Why has there been such a spotlight on hail damage in recent years?
Yeah, I mean, it's a good question. Well, I mean, from a physics-based perspective, it's either kinetic energy or momentum or somewhere in between. So even if you have a small sized hailstone, the speed that the hailstone falls, which is oftentimes faster than terminal velocity because of wind, and also the volume of hail. So, you know, hundreds of thousands, millions of hailstones falling all at the same time can cause modules to break. And the other thing I'll mention is that, you know, we do see a lot of hail that's much larger than golf balls. So we have, we have all sorts of different ball sizes and fruit sizes. So we have like baseballs and softballs and grapefruits and so forth. So it's, a golf ball is actually relatively small compared to a lot of hail we see.
Wow. So what did VDE Americas and RETC do to address the gap in hail risk data and insights?
Yeah, well, I'll mention that. But the other thing I just wanted to note about like why we're seeing so much more damage is a lot of people think it's because of climate change, and climate change could have a factor, but it's probably a relatively small factor. We do see more what are called La Nina years, where there's essentially like a coldness of the North Pacific that causes the jet stream to come down from Alaska and through Canada farther south into the United States, mixing with moist air from Mexico and the Gulf of Mexico. And those La Nina years cause more hailstorms. And we have had a lot of La Nina years recently, possibly because of climate change. But the other thing that's happening, which is the biggest factor, is that we're simply seeing a lot more utility scale PV projects in hail-prone areas like Texas and the Midwest. And on top of that, we're seeing larger modules with thinner glass, bifacial modules, the dual glass modules. So on the chances of getting hit by hail are much greater because there are more projects in these hail-prone regions, and the modules are more delicate. So to answer your question, the next question about what we're doing to try to solve the problem, you mentioned our sister organization, Renewable Energy Test Center, RETC, based in Fremont. They're owned by the same parent, VDE, based in Germany. And we've done basically two major sort of work initiatives. On the VDE Americas side, we've developed a meteorological and physics-based model that helps utility scale developers and operators and financiers understand the risk of hail at specific locations, and also using different types of PV modules at different tracker tilts. And then on the RETC side, since they're a test lab, we co-developed a new test that's called the Hail Resiliency Curve Test that takes a palette of 25 to 30 randomly selected modules and subjects them to up to 20 different shots from a pneumatic hail cannon that shoots freezer ice balls up to 90 miles per hour. And with that testing, we're able to simulate the probability of failure at different kinetic energy levels for individual PV modules. That, combined with our physics-based model and meteorological data, gives us a really good estimate of what the hail loss would be at a particular area with a specific PV module.
So you talked about the hail resiliency curve and the probability, that it gives you that probability. So based on the probability, how does that translate to quantifying financial risks for customers of solar installations?
Yeah, it's a very good question. It's really hard to do. Hail is, it's not like solar resource. We don't have hailstorms every single day, right? So we don't have as much data as we have for a solar resource. So it's actually pretty hard to understand what the hail risk of loss is at any one particular location. So what we did was we work with a meteorologist from Central Michigan University named Jon Allen, who's really like one of the world's foremost experts on hail. And we take data from the National Weather Service that's available from a radar system called NEXRAD, and then we calibrate it using data that is also available from the National Weather Service, but it's estimates of hail size that is called in by people who are called spotters. These are like weather enthusiasts, right? And that combination gives us a sense of how big the hail is in any particular region. So we'll take a project location, we'll take a 100 by 100 area around the project location, and that typically gives us enough data to forecast the risk of loss based on different frequency of hailstorms and intensities of hailstorms over 10, 20, 40, 100, 500, even 1,000 years. That combined with the physics that I was talking about before, the hail resiliency curve, and then importantly, a replacement value, cost per watt, dollars per watt, on how much, estimating how much it would actually cost to replace these modules if they're broken. That gives us the ability to estimate the risk of loss over a 500-year period, over a year period, on a yearly basis, or like a 40-year period.
Right.
Yeah.
So project stakeholders, OEMs, developers, and insurers.
Yes.
Can use your information and your data and your mapping tools in order to reduce the risk of hail damage.
Yes, that's right. Yeah, insurers, thanks for bringing up insurers. They are a huge user of our probable maximum loss reports to understand. They use it to understand what the coverage levels should be. They're called the sublimits for hail, based on different locations, of course, but also different equipment combinations. So like hail hardened modules, wood trackers that can go into hail stow at different angles. And then to your point about the maps, so we sell a number of ArcGIS maps that project developers use to get a very quick initial view on what the hail risk is based on the project location, but also the equipment that I'm talking about.
Right.
Yeah.
So with hail damage costing so much in claims, identifying that financial value of risk mitigation approaches, it sounds absolutely critical. Have there been any standout modules that VDE has analyzed?
Your module is quite good. I see the volume went up. Yes, and yeah, your module is excellent. So that module, I'm not recalling the exact model number right now. So let me find it here. Yes, the Vertex N series, the NEG 19RC 3.2 millimeter front glass module with a polymer backsheet. So we tested that, and we would consider that a hail hardened module, specifically because it has a 3.2 millimeter front glass that is fully heat tempered, as opposed to a 2 millimeter glass module. The problem with the issue that we run into with 2 millimeter modules in hail is that 2 millimeter glass can't be fully heat tempered. It can be heat strengthened, but not heat tempered. So on average, it's about twice as weak compared to a 3.2 millimeter front glass like the Vertex N series NEG 19RC. So yeah, we would definitely recommend that for a hail prone area.
Well, thank you for that. So what's on the horizon for VDE Americas?
Oh yeah, it was very interesting. So hail is, as you would expect, it's not only a risk to solar in the United States, it's a risk around the world. So we are in the process of, I would say, fleshing out a new international service that's based on some scientific work that was done a few years ago that will allow us to actually correlate the risk of hail anywhere in the world using mostly satellite data, but also ground-based data, and comparing it to locations in the United States where we have like a really good radar and spotter data set, that data set I talked about earlier. So yeah, we're expanding internationally. We're also, this is not necessarily related to hail, but we're setting up a new start of construction verification service. So our bread and butter at VDE Americas is actually independent engineering and owner's engineering work. And start of construction is a requirement now to get tax incentives, and so it's a very important need in the industry that we are filling by doing reviews of start of construction evidence.
Well, that sounds great.
Yeah.
I want to thank you so much for joining me here for Trina Talks live in Las Vegas.
Of course.
I hope, it sounds like you have so much going on, and especially expanding internationally and continuing your analysis of what's happening with this hail problem.
Yes.
I'd love to have you on the show again. I hope that we can do this again.
Excellent. Yeah, thank you so much, Melissa. I really appreciate it.
So, hail damage risks are not going away. In fact, they're only getting worse. So if you are looking to save more than $1 million in average annual losses, Trina's series of hail-hardened Vertex modules deliver the durability and the reliability that you need. So you can spend less time worrying about hail and more on your golf game. And if you're here in Las Vegas, swing by the Trina booth. We'd love to have you test out our custom golf course. Be sure to click the link in the description to learn more about our hail-hardened modules. Then join us live this afternoon. We have another Trina Talks episode at 3 o'clock where I'll be joined by Clark Galloway, who is the Southeast Sales Manager with Sologent. We're going to be talking about the showdown between solar panels and Florida's extreme weather. So don't forget to hit the like button and subscribe and share this episode with your project team. Stay tuned for new episodes of Trina Talks. They are live, or they are dropped on the first Thursday of every month. Until next time, may your LCOE be low, your efficiency high, and your systems optimized. Thank you for joining us today. I'm Melissa Cavanagh, and this is Trina Talks. Thanks, Jon.
Thanks, Melissa. Nice job. Okay. Thank you. Thank you.
Thanks, everyone.